All right, so let's try example number 4. When coffee makers are sold for P dollars each, customers will buy DFP equals 31,737 all over the quantity 3P plus 1 coffee makers. The price of the coffee makers T months from now will be P of T equals 0.06 times T to the power of 3 over 2 plus $38. Compute the rate of change of the monthly demand for the coffee makers 23 months from now. Determine whether the demand is increasing or decreasing and at what rate. So here we have an example where we have to go back and summarize what we're given. So let's start with the customers will buy this much amount of coffee, right? And in this example, it looks like the demand depends on the price, right? So the price of the coffee makers T months. So this is the price. Depends on time, right? On the time of the year. And so what they ask us to do is compute, right? Compute the rate of change. That means something with derivative of the monthly demand. Monthly demand is actually this one, right? The demand of this monthly at the 23 months. So they're asking us to find the rate of change, and remember that's a derivative definition. So they're asking us to find d of d over dt. Yeah, when the time is 23 months. Right. So determine the demand, whether demand is decreasing or increasing, and at what rate. So basically, it's clear here that we have to find d over dt, right? So let's go ahead and do that. Since this is in respect to time, right? That means we're gonna treat p as a function of time. Treat p as a function of time. Time t. Okay, perfect. So when we take the derivative of d over dt, this is going to be actually, before we do that, maybe I will suggest here a small thing. Let's do something to this. If we try to do the derivative this moment, we probably would have to use quotient rule because we have a function over a function. But there's an alternative way we can do this. We can think about this as being a power of 1, and since there's only a constant on top, we can move this to the top. What I mean by this is DFP is equal to 31,737 times the quantity 3p plus 1 to the negative 1. Remember that when you move when you move the denominator variable, the power changes its sign. So this, I think, if we do it this way, when we take the derivative of this, we'll only have to use the chain rule, and I think we agree that chain rule is much easier than the quotient rule. So let's go ahead and try this again. So d of d over dt, the derivative of this function will be the constant is carried over, and multiply this by the derivative of this, right? By using the chain rule, we'll bring down the negative 1, leave the inside as it is, take away 1 from the power, right? So negative 1 minus 1 is negative 2, and then multiply by the derivative of the inside. What is the derivative of this? Well, remember that p is treated as a function of time, so that means that this is going to be 3 times the derivative of p in respect to time. So this will be 3 times dp over dt plus the derivative of 1 in respect to time, which is 0, right? It's a constant. So we have everything we need it seems like we have found the derivative, but we need to know what is the price, and we need to know what is dp over dt. We are actually not given those values. We're not given those values. We're not given the price. We're not given the rate of change of the price over time. But we're given the other function, so somehow we must be able to use this, right? So let's use some side work here. Side work. So let's find first the price. Here, all we need is to know what time of the year to find the price, right? So at t equals 23, the price will be 0.06 times 23 raised to the 3 halves plus 38. If we put this in the calculator, this will be 44.61824. So we found the price. We know what P is, right? Now we need to find what is the corresponding dP dt. What that means, we're going to have to take the derivative of this in respect to time. So let's go ahead and do that, right? The derivative of this in respect to time. Well, let's look at this one. Well, it will be 0.06 times the derivative of t to the 3 halves. Well, for that we use power rule times t. So bring down the power, leave the t as it is, and subtract 1, right? So 3 halves minus 1 is 1 half, plus the derivative of 38, which is a constant, which is the derivative that will be 0, right? So we're not going to write it out. So to find the derivative of this at 23, all we got to do is evaluate when t equals 23, which equals 0.06 times 3 halves times 23 to the 1 half. And if we put this in the calculator, we're going to get something in the form of 0.43 1624837. So we have all those numbers, and we're going to go ahead and plug it in here now. Maybe we can multiply these two together. This will give us negative 31,737 times 3 times this number, plus 1 to the negative 2 times 3 times this this number, which is right here, dp dt. So it will be times 0.431624.8. And when you put this in your calculator, the end result is going to be negative 2.2597, and so on, right? So we found dd over dt whenever t equals 23 months. So depending on the day of the year, right, or the month, right, but 23 months. So therefore, what we have here is, if we go back and answer the questions, compute. And so they ask us, what is the demand increasing or decreasing? And so we can see, because it is negative, the rate of change of the demand is negative. That means the demand is decreasing at a rate of 2.259753698071, right? If we want to put all those numbers, so we were able to find at what rate it was decreasing. So there you go, right? So again, the what we want to get from here is be able to think about the approach that we are taking, be able to translate the problems into mathematical expressions, and then use that to solve the problem. The key factors are be able to translate them into quantities, rate of changes whenever that's given, summarize the function they're given, or be able to find a function for which they all relate, and then taking the derivative. And for the most part, if you remember there's always a variable that is treated as a function of time. So we always have to keep that in mind and be able to make the right conclusions, right?